The augment assignment operators are operations combined with assignment. These operators provide a concise way of updating the value of a variable based on its current value in another operand. There's 5 of these examples in numeric operators in Java. The very first one is the addition assignment plus equal. So this is the shorthand for writing equals and plus in between variables. So for example, if you have an integer I, let's say 0, and you wish to increment I by a value of 8, meaning I equals I plus 8, you can transform this into a shorter writing with a plus equal sign. So this becomes I plus equals 8. Same thing with subtractions assignment, where you can shorthand I equals I minus 8 into I minus equals 8. Same thing with multiplication, start equals division / equals, or remainder quotient assignment, percentage sign equals. Note the conventions here. You would not write, for example, additions assignment with equals plus. This is not syntactically correct. So note the equal sign being on the right side. Addition, subtraction, multiplication, division, and remainder operators will be on the left side of this shorthand writing. You'll see this type of augment assignment operators in bitwise operations as well, even though bitwise is beyond the scope of this discussion. The reason why we have augment assignment operators is because they provide a concise way of writing code. On the flip side, it makes code more readable. This type of operators are commonly used in many OOP languages, Java, C++, to simplify code and improve readability. Speaking of the shorthand way of writing operations, let's look at both increment and decrement operators in Java in the next slide. The increment or plus plus and decrement or minus minus. These operators are used to increase or decrease the value of an integral variable by 1, respectively. These operators can be used in both prefix and postfix form. Prefix as in assuming var is an integer value. The prefix means appending plus plus or minus minus in front of the variable, like this. So both of these represent prefix form of increment decrement. You also have postfix or suffix form of your increment decrement. So this will be postfix. Let's just use the increment as an example. Whenever you have a prefix version like this one, it increments the value of the variable by 1. The incremented value is then used in the expression where the operator appears. For example, if you have an integer x equals 5, and you would create another integer y by incrementing x in a prefix way. So what happens is, since plus plus literally means x equals x plus 1, you're incrementing your x by 1 over here, which results in your right-hand side being 6, because 6 is 5 plus 1, which means this value 6 is assigned into the variable y. This also means that x is also 6 at the end of this increment. You can extrapolate this by using minus minus as well. Let's look at the post increment, where you have the same thing, x equals 5, but you want to do x plus plus. So what happens here is this operation uses the current value of the variable, x equals 5, in the expression where the operator appears. The difference between this pre-increment and the post-increment is in the post-increment, the value is used, meaning it is assigned first, which means x, which is 5, becomes the value of y. And then the increment happens after x is used. This means that after the value is used, the variable is then incremented by 1. So x is 6, y is 5. Whereas in this example, pre-increment, both x and y are 6. The same concept applies to pre-decrement and post-decrement. Just remember, whenever you have a prefix, the evaluation happens first. Whenever you have a postfix, that means the evaluation of that increment or decrement happens after the variable is used. That means the value will then be either increment or decremented after it is assigned to another variable. This is a very important distinction because it is important to note that the behavior of these operators can lead to different results depending on whether they're used in a prefix or postfix form. These operators can only be applied to variables and not constants or literal values. When these increment and decrement operators or unary operators are used in the context of a complex expression, sometimes they can lead to unexpected behaviors due to the associativity or the precedence, the order of evaluation. It is generally recommended to use them in isolations or in simple expressions to avoid confusion. Let's look at some more examples. You have an integer I equals 10. What you have here is a new num equals 10 times I plus plus. Notice that this variable must be used before it is incremented since we have plus plus in the postfix form. Therefore, in this expression, what you have here is integer new num equals 10 times I. And then after that, I is incremented by 1. On the other hand, if you have a prefix I, the effect is that you would increment I and then you would do 10 times I. So both of these examples will lead to very different results. Therefore, it is crucial that you understand the effect of postfix and prefix increment prior to using it. Here's one more caveat. Avoid using these unary operators for incrementing and decrementing your values in a complex expressions, such as this. One, it makes your code a lot more difficult to read, to understand. Also, it is hard to predict what the value of it is. It also makes your expressions a lot more complex than necessary. Rather than doing this, you will simply just separate them, meaning I equals I plus 1. And then you can do integer k equals I plus I that way. The other thing about these operators is they take precedence over the normal addition sign. So the above will yield the following. This concludes our discussions on increment and decrement operators.